let's talk about absolute values. So the absolute value of a number is the numerical value without the sign. That means that a negative number becomes positive and a positive number stays positive. So let's think about what that means. If we're looking at the number line, and I have a little 0 on there, and I go to the right, 1, 2, 3, 4, 5 steps, or I go to the left, 1, 2, 3, 4, 5 steps. If I go to the right 5 steps, I end up at a number that we call 5. 1, 2, 3, 4, 5. That's to the right of 0. If I go to the left of 0, 1, 2, 3, 4, 5, I get to negative 5. But there's something same about both of these. Both of these, I'm going a distance of 5 from 0. So in a way, we could think about the absolute value as thinking about the distance traveled between 2 points or 2 locations on the number line, regardless of the direction. Because really, going this way 5 steps is 5, and going that way 5 steps is also 5. The only difference is the direction. One is in the positive direction and one is in the negative direction. So taking the absolute value says, I don't care what direction, how many steps did you take? What's that length there? So if we're thinking about it that way, and we want to start to think about doing math with it, we have some rules that I want you to keep an eye out for. So the rule is when you're computing expressions with an absolute value, do whatever's inside the lines first. And then strip away the negatives between the lines. So let's look at an example, and I'll tell you some things that people might be tempted to do, and then how you're going to avoid them. So a lot of people say to me, well, Donna, we have absolute values around these guys here. Does that mean I should turn everything in there as positive? So that's positive 10, but now that's positive 8. So it's actually 8, absolute value of 18 in there? No. You must compute what's inside the lines first. Do whatever's inside the lines first, then strip away any negatives between the lines. So let's try that. If I were to simplify what's inside here, 10 minus 8, that's 2. Absolute value of 2 is positive 2 because it's already positive, it stays positive. Now, someone might try to do that on this side as well. They're saying, oh, Donna, it's negative. We have absolute values. Let's make it positive. Let's make it 5 plus 11. No, that's not right. That's not right. We have to compute what's inside first. 5 minus 11, that's negative 6. So what we're saying is we want the absolute value of negative 6. What is the magnitude of negative 6 without the positive or negative direction? Well, that's just 6. And now we can take these guys, now that they're both outside the absolute values, subtract them, and we'll get negative 4. Now, I do get the question a lot, Donna, how do you get a negative answer if you had a bunch of absolute values up here? Aren't absolute values always positive? Well, when we take the number out, they're positive, but once they're out, if I take a small positive number and subtract a bigger positive number, I'm going to get a negative value. So yes, absolutely, the answer can be negative. So let's continue to think about this. Solving for a variable within an absolute value really just requires acknowledging that an absolute value hides some information from you. If I take the absolute value of something and get 7, what that means is when I took the absolute value of something and I got 7, I don't actually know what that x is. There are 2 ways this could have happened, right? I could have taken the absolute value of positive 7, and that would equal 7. Or I could have taken the absolute value of negative 7, and that also equals 7. So wait a minute. Do I know which one it is? No. That x in there, that x in here could actually be 2 things. It could be 7, or it could be negative 7. Now, how do I write that in math? That x right there could be 2 things. That x right there inside the absolute value has 2 options. It could have been 7, and it could have been negative 7. Don't confuse when I say x could have been 7 or negative 7. X could have been, not the absolute value of x. Once I take the absolute value, it has to be the positive 7. But what could the x have been? The x could have been 7 or negative 7, right? So whenever you're trying to solve for a variable, we can't really solve for it when it's inside the absolute value. So we have to kind of bust it out. And when we bust it out, we always set up two equations, one for the positive version of what x could be and one for the negative version of what it could be. I actually misspoke there, not what x could be. The positive version of whatever is inside the absolute value is what it could be. Or what's in there could be -7. Let's see another situation. What if I took the absolute value of x plus 3 and that equaled 7? Well, whatever is inside there, just like the x was inside here, whatever's inside here, when I took the absolute value of it, it equals 7. So that means whatever's inside there, the x plus 3, could actually have been two things. It could have been 7, or it could have been -7. Because when I took the absolute value of it, this x minus 3 business, it either x minus 3, that's what's inside the absolute values. I took the absolute value of it and I got 7. So that means it could equal 7 or -7. Now, if I want to find out what x is, I just do a little bit of algebra. -3, -3, -3 on all sides. Over here, I'll get that x equals 4. And over here, I'll get that x equals -10. Now you might be saying, Donna, how can two things work in an equation? Well, let's try it out. If I go back to this guy and say, okay, the absolute value of my x plus 3 equals 7, if I put the 4 in there, well, 4 plus 3, that's 7. Absolute value of 7 is 7. That works. Now, what if I do the same thing with the -10? Well, -10 plus 3, well, that's -7. And the absolute value of -7 is 7. So keep an eye open that whenever we're going to bust something out of its absolute value bars, when there's a variable inside, we're going to make sure to set up two equations, one for the positive version of what's in there and one for the negative version of what's in there. I'm going to add a little page because I want to say a little bit more about this. Because if you think about it, if I have the absolute value of 2x plus 3 equals 8, let's say we're looking at this. This thing in here, the idea is if that was, say, 8, then it would have a positive on it, and we would just take it out and say 8 equals 8. If that had a negative on it, it would be the negative version of it. We say absolute value of -8 equals 8. So then 8 equals 8. Okay, just thinking about that idea that the thing inside could be the positive or negative version of itself. If we have 2x plus 3 in there, either this thing in here is actually 2x plus 3. So when I take the absolute value of it, I got 8. Or it's the negative version of whatever that thing was in there. And that equals 8. If I multiply both sides here by -1, you'll see I get the same setup as I had last time. These negatives will cancel. I'll have 2x plus 3 equals -8. And that is just the positive and negative versions we were setting up before, right? 2x plus 3 equals 8, or 2x plus 3 equals -8. Again, it just depends on which side we put the negative to start. So thinking about the idea that, thinking about the idea that what's in here could be the positive, what's inside here could be the positive or negative version of that. Again, we could write it like this, or we could write it like this. Again, having the positive on this side and the negative on this side, or the negative on this side, the positive on this side, they are equivalent equations. Another thing I want you to notice is that absolute values are always positive. So what if I got the absolute value of x plus 2 is -1? Ask yourself, how many solutions would there be to this? What if I put a 5 in there, or a 7 in there, or a -3 in there, or 102 in there? Am I ever going to get out a -1? The answer is no. And why? Because no matter what this is in here, I'm about to take the absolute value of it, which will turn it positive, and therefore it could never equal something negative. So this would be no solution to this question. So for x, there is no solution. It'll be the same sort of situation if we ever have like x minus 3 is less than 0. That's never going to happen. It could equal 0. If x is 3, we would have the absolute value of 3 minus 3. That it could equal 0, sure, no problem, because the absolute value of 0 is 0. But what we couldn't ever have is an absolute value being negative, less than 0. So again, that would mean no solution. All right. So let's try one. And again, we're going to remember to set up both equations. This thing in here, it says if the absolute value of n minus 12 equals 7, what's one possible value of n? This language, one possible value, means that there's going to be multiple possible values, but you only need to put one into the student-produced response. So we're going to set up two equations, one for each of these absolute value bars, one for the positive version, and we're going to set up another one for the negative version. Okay, you can think about one for each of the absolute value bars. So for the positive equation, we'll say n minus 12, exactly what's in there, equals 7. And then one where that thing that's inside the absolute values, exactly as it's written, equals the opposite. And now we can solve. We'll add 12 to both sides, and we'll get n equals 19. Add 12 to both sides, and again, we get n equals 5. Now, if you're doubting me, we can pop it back in. When you put a 5 in here, does it work? 5 minus 12, that's negative 7. Absolute value of negative 7, oopsies, I'll try it again. Negative 7 is 7, so that one works. And let's try 19. If I pop a 19 in here for my n, 19 minus 12 is 7. Absolute value of 7 is indeed 7, so that one works out as well. Fabulous. Now let's do a lot of practice. Remember, when we have just numbers inside, we're going to go ahead and do the inside of the absolute values first. So 8 minus 2, that's 6. Absolute value of 6, that's going to be 6. So the answer is 6. Here we have the absolute value of 2 minus 8. What 2 minus 8 is? That's negative 6. Absolute value of negative 6 is 6. Now you might be saying, Donna, why is this happening? How come I'm getting 6 for both ones? Well, absolute values are often distances, yes? What if I said, okay, here's 0, 1, 2, 3, 4, 5, 6. Let me get this a little bit longer. 7, 8. So we have 8, 7, 6, 5, 4, 3, 2, 1. And what if I said, what's the distance from 2 to 8? Well, you might be saying I can go 1 step, 2, 3, 4, 5, 6 steps. Or if I ask you what's the distance between 8 and 2, you might say 1, 2, 3, 4, 5, 6 steps. You'll notice one went from left to right and one went from right to left, but both had the same amount of steps. And if you want to compute that, calculate that, you might say what's the distance between 8 and 2. If we're only going in one direction, we'll just subtract 8 minus 2. We get 6. Now, if I do it in the other direction, 2 minus 8, I get negative 6, but I didn't ask for the direction, just the distance. So if I put absolute value bars around this, boop, 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 now I get 6 for both, and that just gives me the distance, the magnitude without the direction. So it doesn't matter if we're going from, put the absolute values around the 6 here. It doesn't matter if we're going the distance between 8 and 2 or 2 and 8. What we're saying is the distance between them is both 6, regardless of the direction. All right, let's take a look at the next one. Here again, we're going to do what's inside the absolute values first. 6 minus 15, that's going to be negative 9. Minus, again, when these guys are next to each other, that means multiply. 5 times negative 4, that's negative 20. And now we're going to simplify it by taking it out. This whole thing, when I take the absolute value of negative 9, it clears the negative and becomes 9. Minus the absolute value of negative 20, well, it clears the negative and it just becomes 20. So if I do 9 minus 20, I actually get negative 11. Again, smaller positive minus a bigger positive will give you a negative. Ooh, now here we have variables inside the absolute values. So I took the absolute value of some unknown thing, x minus 2, and I got 6. Well, that means that x minus 2 could have been two things. That could have been two things. It could have been 6, so I took the absolute value of it and got 6. Or it was negative 6, so I took the absolute value of it and got 6. So let's solve by adding 2 to both sides, x equals 8. And again, solve by adding 2 to both sides, x equals negative 4. Let's test them out and make sure they work. If I put an 8 in here, I get 8 minus 2, that's 6. Absolute value of 6 is 6, so it works. Let me try the other guy. If I put negative 4 in here for my x, negative 4 minus 2, well, that's negative 6. Absolute value of negative 6 clears the negative and is 6, so we can see that they both work. You might notice that if these questions are kind of like this, and then they give you options for answer choices, like A, B, C, and D, this would be a great opportunity to possibly back solve it to solve. All right, let's set up the last one. If I take the absolute value of x plus 11, it equals 23. What are all the possible values of x? Well, let's remember whatever's in here, I took the absolute value of x plus 11. So I took the absolute value of it, and because it's inside, when I take it out, it can equal two things. It can equal 23, or it can equal negative 23. So when I took the absolute value of it, I got out 23. Let's solve by subtracting 11 from both sides here. We'll get x equals 12. And if I subtract 11 here, I'm going to get x equals negative 34. All right, beautiful job. And I'll see you in the next video. Wanted to talk about a little bonus topic when it comes to absolute values with inequalities. Let's think about what this means. Say I have the absolute value of x is less than 8. I'm looking on the number line at things that work in here. If I put in a 3, it'll work in here. The absolute value of 3 is 3. Absolute value of 3 is 3, and 3 is less than 8, so that one works. So this point here should be shaded on my number line. If I put in a 4, it'll work. If I put in a 5, it'll work. All this should be shaded, right? If I put in a 0, it'll work. It should be shaded. All these values will work. When does it stop working? Well, when I get to things that are bigger than 8. So 6, 7, 8. 8, it kind of stops right here. 8's not going to work either because the absolute value of 8 is 8, and 8 is not less than 8. It's equal to 8. So that'll be open right there. That's when it'll stop working. And everything above, like 9 or 10, that's not going to work either. Now, I wonder if I can go on infinitely in the negative direction. Well, negative 1 will work, negative 2, negative 3, negative 4, negative 5, negative 6. I put a negative 6 in here. Absolute value of negative 6 is 6, and that's less than 8. So that'll work. Negative 7, negative 1, no, what am I on? 1, 2, 3, 4, 5, 6, 7, 8. When I put negative 8 in there, does it work? It does not, because the absolute value of negative 8 is 8, and 8 is not less than 8. And that, for that same reason, negative 9, negative 10, when we take the absolute value of them, they become bigger than 8. So what we're doing is we're shading in here. And what it looks like is everything that's less than 8, that's also greater than negative 8. That's what will work. So the question is, how will we set this up algebraically? Well, we'll just take this absolute value and set up these two equations, one for the positive and one for the negative. Just like we did with the equalities, we'll say the thing inside the x is less than 8. Notice it looks exactly like our original equation without the absolute values. And then for the negative one, you just want to remember that it's negative x, the negative thing inside there, the negative whatever's inside the absolute value is also less than 8. Now, if we want to simplify, we have to remember one very important thing about these inequalities, yes? When we multiply or divide by a negative, we must flip the inequality. So if I go like this and I multiply both sides by negative 1, I'll get that x is greater than negative 8. So at the end of the day, we want to end up with the equation that looks just like the one that we had originally, and one that has what my little guys call the flippy switchy. You flip the inequality and you switch the sign. Let's set up another one. Say I had the absolute value of x minus 2 is greater than 9. My two equations I would set up would be x minus 2, the positive version, and negative x minus 2 are greater than 9. Both of those things are what x minus 2 could be. X minus 2 could have been x minus 2, but it could also have been negative x minus 2. And then again, oops, I must have dropped my 9 there. We can solve by adding 2 to both sides. We'll get x is greater than 11, or if I multiply both, I can also just, distribute the negative in here if that's easier. Negative x plus 2 is greater than 9. subtract 2 from both sides, I'll get negative x is greater than 7. And at this point, I want x, not negative x, so I'll multiply both sides by negative 1. But what do I have to remember when I multiply both sides by negative 1? I have to flip my inequality. So I'll get x is less than negative 7. And these are the two solutions. X is greater than 11 or x is less than negative 7. So again, remember you set up two equations, one for the positive version of the situation and one for the negative version of the situation. Okay, I want to talk about something that doesn't come up that often, but if you're still watching now, you're here for the details, so I'm going to give them to you. So if we're graphing an absolute value equation, y equals the absolute value of x, I think a great way to explore what these kinds of graphs look like, it's to kind of plug in some x's, get out some y's, and see what we're working with here. So let's make a little t-chart for ourselves so we can track our inputs and outputs. X's will be our inputs, y's will be our outputs. So we put in -3, -2, -1, 0, 1, 2, 3. Let's see what our corresponding y values would be. If I put a -3 in here, absolute value of -3, well, that's 3. So y would equal 3. That's going to be my y value. Let's do the same with -2. Put in a -2. Absolute value of -2 is 2. Put a 2 here. If my x is -1 and I take the absolute value of it, absolute value of -1 is 1. My y value is 1. Absolute value of 0 is 0. Absolute value of 1 is still 1, then 2, then 3. So now we can say if I put in my x, I'll get out that corresponding y. X's are graphed along the x-axis. Y's are graphed along the y-axis. So we'll go over to the x value of -3, 1, 2, 3, and up to the y value of +3, 1, 2, 3, and I'm going to put a point right here. -3, +3, and that's the point, -3, +3. And then -2, +2, boop, boop. I'm going to put a little point here. Then I'm going to do -1, +1, then 0, 0, then 1, 1, 2, 2, 3, 3. You can see I'm making kind of a fun shape. I am making a V shape. So when you graph an absolute value, you get a V shape. Why? Well, let's think about what would happen if I just graphed y equals x. That's a very familiar line. You might notice it looks like this. For any x value, the y value is the same. So it goes like this. But what happens with an absolute value is this portion here where the y's would normally get negative. If I put in a -1, I would get out a -1 for my y, because y equals whatever x is. So if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2. If x is -1, y is -1. But here, if x is -1, the negative gets cleared. So while I still have negative x's, what used to go down now will go up. So basically what we have is as soon as the line would head into negative territory, it says, flips back around and reflects positive up. Yes? Now, this is not the only sort of graph we could do, right? I can move this guy around. If what you'll know when we do transformations to keep an eye out for is if you mess with the x's, it messes with the horizontal, like the x-axis goes horizontally. If we mess with the y's or the entire function as a whole, we're going to move it vertically. So let's look at some options right here using Desmos. I'm going to split my view here. Grab a little Desmos, there we go. So if I want to graph the absolute value of something, you'll see I have a little button here on the third down on the left, the absolute value of x. If I just graph that, you'll see this familiar shape that we've just been working with. Look what happens when I add 2 to it. Well, let me do that on a separate line. If I have the absolute value of x, close my little absolute value there, and add 2 to it, how does the blue graph look different than the red one? Well, it's been shifted up 2. Why? Because you can see from my equation, if I have the absolute value, y equals the absolute value of x, and then I take whatever that was and add 2 to it, each of my y values that I had before, each of these y values that I had before, I'm just going to duplicate it here, will be whatever they were before, but they'll be 2 bigger because I just added 2 to them. So plus 2, plus 2, plus 2, plus 2, plus 2, plus 2, plus 2. So all my y values will be 2 bigger than they were before. They'll be 5. Sorry, these are negative. It'll be negative. Oh, sorry, no, those are positive. Excuse me. Absolute values don't have negatives. Thank you very much. That'll be 5. That'll be 4. That'll be 3. That'll be 2. And then it switches back around, back to 3, back to 4, back to 5. So you'll see it still has that same symmetrical effect, but everything's been shifted up 2. So we wouldn't put it in at negative 3, 3. We'd put it in at negative 3, 5. We put it in at negative 2, 4. We put it in negative 1, 3. So again, you can see we still have that same shape because it's an absolute value, but it's been shifted up. Now, what happens if I add 2 inside the absolute values where the x lives? What do you notice? It's shifted to the left. Now, this might be unexpected, but we'll talk about this more in our transformation conversation. But if we are adding 2 to it, it actually moves in the opposite direction when we're messing with the x's. X's are super persnickety, right? So let's see if we can anticipate what would happen if we did the absolute value of x minus 3 plus 5. Let's see if we can tell what would happen. Well, if we're looking at this, we know it's going to be that beautiful V shape we have here on the right, but it's going to be moved up 5 because that's happening outside the absolute values. And I might be tempted to say, okay, this is being done to the x inside the absolute values so that it should move to the left because it's negative, but no. When it's negative, we always do the opposite direction of what that sign indicates. That's actually going to go to the right 3. So let's see it. Let's see this guy. If I take the absolute value of x minus 3, close my absolute values, plus 5, take a look. I move to the right 3 and up 5. Count it out if you like. Over to the right from the origin, 1, 2, 3, up 1, 2, 3, 4, 5. So again, we can look at these equations and see what the graph might look like.